Okay, so we're supposed to find all of these 5 things: domain, range, vertex, axis of symmetry, and transformations for the function f of x is equal to 1/3 x minus 3 squared plus 4. So, what is the easiest thing to find? I think the vertex, yes. Why is that easy? What do you look at?
The equation.
Okay, good. Look at the equation. Where do you look in the equation?
You look in the parentheses and what's outside the parentheses.
Your H and your K.
Right, yes. Now, does that mean that my vertex is -3, 4? And I'm done.
No,
Why not?
because you have to switch the sign in the parentheses.
Ah, yes. Remember, inside of our parentheses, I don't know if I'd let you have paper if I knew that's what you're going to do with it.
This is our bet.
Oh, that was your bet? Okay.
We got a pro.
Not yet. No, not right now. So, inside parentheses is always backwards. So, if it says -3, our vertex, our x value is what?
3.
A +3. And the 4, do I make that negative?
Yeah, that's just right.
Right. 4, because it's outside the parentheses, is normal. Now, because we know the vertex, what is it easy to now find? The axis of symmetry. Why is it easy? Because all we have to do is look at the h value, and that is where the axis of symmetry is, right? That h value moved the graph 3 to the positive, so that means the axis of symmetry was moved 3 to the positive on the x-axis. So the line is x equals 3. What about transformations? What's happening here? There's 3 transformations happening. Yeah, first is the vertical compression. Why is it a compression?
Because the A is
Very good, because the A value is less than 1. It's a third. Now, I forget where I saw it, but I don't know if it was in this class. It might have been in another. There was a number in front of a function of 4/3, and someone said, oh, that's a vertical compression. Is that a vertical compression? No, why not? It's bigger than 1. Yes, it's a fraction, but it is bigger than 1. So that is actually a stretch. So vertical compression by how much? 1/3. Vertically compressed by a third. What else is happening here? Right, so if it's translated right, is that vertical or horizontal? So it's a horizontal translation, horizontally translated, which way, left or right? Good. Remember, it's backwards. So it says -3, but inside it's backwards, so we add 3. We're going to the right 3. And lastly, what is our last transformation? Vertically translated up 4. Wonderful. Any questions about our transformations? Okay, so now domain and range. I asked you guys to find both of these in set and interval notation. Now, I don't know about you, but personally, I have a hard time looking at a function and just knowing the domain and range. What I do in my head, and sometimes I even sketch it, and I'll sketch it for you guys, is I sketch the graph, just so I can have a little visual representation. So here, I know that this was moved to the right 3 and up 4. So there's our vertex, and it was compressed, so it is wider. So, what is our domain of this function? And in fact, what is the domain of every single quadratic, no matter what? All real numbers. So, if I'm trying to find the domain in set notation, what do I write? Right, yes. Because set notation we know is set builder notation. You're building that big long thing. So it's the curly bracket. X is in all real numbers. What about an interval notation? What would it look like if it was an interval notation? Right, and we do parentheses because you can never be infinity, right? You can never touch it. This graph is never actually infinity. So we do negative infinity to infinity. Now, range. I always ask myself, I look at the graph, and I say, okay, what is my least y value that the graph goes to? 3. Oh, no. My least y value? 4. And what's my max y value? Infinity. So all of our y values are what? Bigger than, which is greater than 4. So what is my set notation going to look like? Such that, yep. Right, why is it equal to? Why do we put equal to there? Because we actually have a y value of 4, right? The coordinates of this point are 3, 4. It's touching 4. So it's equal to. Y is greater than or equal to 4. I did give the sticky note back to some people that got that symbol flipped. So make sure you're checking that you have the greater than symbol here. Ask yourself, am I going up or am I going down from that number? If your answer is you're going up, then it better be greater than. If you're going down from 4, then it should be less than. And what is this going to look like in interval? What's our lowest point? We always do least to greatest. 4. Right. Why is it bracket? Yes. You have a y value of 4. You're touching 4, so you put a bracket. Then what? Right. Comma, infinity, and we can't touch infinity, so you put a parenthesis. Any questions on any of these? Any questions on any transformations at all? Because when we get back from lunch, we are going to take a quiz on this.
Sweet.
Which, I looked at it, and I haven't been here, so I haven't been a part of the planning or creating process. I just looked at the quiz. Oh my gosh, it is the easiest on-level transformations quiz I've ever seen.
You're also a math teacher.
Yes, but I've been teaching this for 6 years, so I've been making a lot of quizzes.
I figured out how to graph it.
Good. Nice. So, when we get back, we're going to take this quiz. Don't freak out. It's not too difficult. There are no trick questions here. Oh, also, what is another word for an x-intercept?
Why?
Zeros. What else?
Twos.
Zeros, x-intercepts, roots. And there's one more. Solutions. Those are all the same thing.